All right, this is video 4 of the Stoic series. We are going to continue on the same track as we were in video 3. So this video is going to review how to find limiting reactants in specific problems. But before we get into any of that, if you could please pause the video and complete section J, which is the day 5 warm-up. So pause the video, do the warm-up, hit play when you are finished. These are the answers you should have gotten for section J. If you did not get these answers, please check with someone around you. Maybe they can explain why you got it wrong. And then we are going to go ahead and get into the example problem number 7 from your packet. So this problem states that 60 grams of potassium is reacting with 35 grams of copper 1 oxide. What is the limiting reactant and how much copper will be produced? You probably know step 1 already, is to write out the chemical equation and balance it. So please pause the video, try step 1 on your own, and hit play when you're finished. This is the equation that you should have gotten out. We have 2 moles of potassium reacting with Cu2O. Remember that you need to crisscross those charges, forming K2O, again, crisscrossing those charges, plus 2 moles of copper. If you did not get this, please try it again, and if you're still not understanding how this equation got to be the way it was, please ask someone around you. The next step is to set up dimensional analysis and to put the mass of one of the reactants. Again, it doesn't matter which, but I am going to be using the first one stated in the problem. So if you want to follow along with me, please do that same reactant. You're putting this value in the upper left-hand box, remembering your units and your labels. So please pause the video, try this step, and then hit play when you are finished. You should have placed the 60 grams of potassium in the upper left-hand box. If you are being a rebel and doing the other one, you would have just simply put the 35 grams of Cu2O in the upper left-hand box. The next step then is to use reaction stoich to convert into grams of the other reactant. So in this case, we are going to go from potassium into that copper oxide. And that answer, remember, is how much copper oxide you need in order to react the potassium completely. So please pause the video, give this a try, and then hit play when you are ready. So when I go through converting from potassium into copper oxide, I got that I would need 110 grams of copper oxide to react with all of the potassium. If you did not get this answer, please check your work again, try plugging it into your calculator again, and if you're still not getting the right answer, please check with a classmate. And again, if you are not understanding the whole reaction stoich process, please go back into video 1 and video 2 and watch those again. The next step is to determine the limiting reactant. So this is where we are going to compare the answer that we just got out to the actual amount from the problem. So please pause the video, give this a shot. This is where I use my money metaphor in case you forgot, and then hit play when you are finished. Now, just as a reminder, if your answer is more than the amount of the substance that you started with, then your ending substance is the limiting reactant. And if your answer is less than the amount of that substance that you started with from the problem, then your starting substance is your limiting reactant. Just remember that you have to compare the same substance. So if you are, you can't compare the copper oxide to the potassium, you have to compare copper oxide to copper oxide. So in this case, we need 110 grams of copper oxide in order to react all of the potassium. From the problem, it tells me that I have 35 grams of copper oxide. So if I wanted to buy something that was $110 and I only had $35 on me, then I am limited by my money. I cannot purchase that item. So therefore, my copper oxide is the limiting reactant. So now at step 5, we are going to use the amount of the limiting reactant from the problem to calculate how much product is going to be made. So just a reminder that you are not using the calculation from the last step. So you are not using the 110 grams of copper oxide. You are using the number from the problem. So you need to start with the 35 grams of copper oxide. So please pause the video, give this a shot, and then hit play when you are finished. When you start with 35 grams of copper oxide, right, we go through the simple mole conversion, we go through the mole to mole ratio, we go through a second mole conversion, and you should have gotten that we would produce 31.08 grams of copper. Please also be careful that you read the question carefully to see what product I'm asking you to calculate, because I could have asked you to calculate the potassium oxide instead, and if you didn't read that problem all the way through, you wouldn't have known that. So please make sure that you are reading carefully and notice how every single one of my numbers has a unit and a label. So please make sure that you are doing that. It's going to save you from making simple mistakes in the future. We're going to now move on to example problem number 8 from the packet, and I will run this the same exact way as the last one. But if you would like to, just pause the video here, try all of the steps on your own, and then hit play to check your work. By all means, please do that. If you would like to work along with me, then you can just keep listening to the video. So problem number 8 says that 150 grams of propane, which again is C3H8, is reacting with 250 grams of oxygen gas. What is the limiting reactant and how much water will be produced? You probably know step 1 already is to write out the chemical equation and balance it. So please pause the video here, do step 1, and then hit play when you are finished. So you should have found that the chemical reaction, when it's balanced, should be as it is stated on this slide. A reminder that you should know that this is a combustion reaction based on the fact that there is a hydrocarbon reacting with oxygen gas, and the products of a combustion reaction are always CO2, carbon dioxide, and water. And then when you balance it, you should get those coefficients stated on the slide. The next step then is to set up your dimensional analysis. You are going to put one of the masses of the reactants given to you in the problem. Again, doesn't matter which, but I use propane in my work on the slide, so if you want to work with me, please do that. You're putting that number in the upper left-hand box, remembering units and labels. So please pause the video, do this simple step, and then hit play. So you can see here that I put the 150 grams of propane in the upper left-hand box. You could have put, or in the future, you can put 250 grams of oxygen gas instead. It's kind of up to you. Again, I just do the first one for simplicity's sake. The next step is going to be to use reaction stoich to convert from grams of the reactant that you started with into grams of the other reactant. So in this case, we are going to convert from grams of propane into grams of oxygen gas. Your answer, remember, is how much of that reactant, so in this case, we're going from propane to oxygen gas. Your answer is how much oxygen gas it's going to take to react all of the propane completely. So please pause the video, give this step a shot, and then hit play when you're done. So through the calculations, right, I went from propane into oxygen gas and found that in order to react all 150 grams of propane, I would need 545.45 grams of oxygen gas. If you did not get this same answer, please go back, check your work, check your calculations, and if you're still not getting this answer, please check with a classmate. The next step is to determine the limiting reactant. Now again, this is the hardest part of all of this. You have to compare your answer, so we have it in grams of oxygen, to the actual amount, or grams of oxygen, that was given to us in the problem. So please pause the video, give it a shot, and then hit play. So through my calculations, I found that I need 545.45 grams of oxygen gas to react all of my propane. But in the problem, it says that I have 250 grams. So that would be like me going to the store. I want to buy something for $545.45, but I only have $250 on me. So therefore, I am limited by my money. The oxygen is going to run out first. So therefore, oxygen is the limiting reactant. Now that I know the limiting reactant, I'm going to use the amount of the limiting reactant from the problem, so that 250 grams of oxygen, in order to calculate how much product I'm going to make. There we go. So why don't you pause the video here, try this for yourself, and then hit play. So through the calculations, again, you need to read the problem when there's multiple products to see what I'm asking you to actually calculate. I asked you to find how much water is produced. So I started with the 250 grams of oxygen. I did reaction stoich into water to find that 112.5 grams of water will be produced. If you did not get this answer, please go back through your work, try calculating it again, and if you're still struggling, please ask another student. This is the end of video 4. I hope this is making sense. If it's not, please take advantage of the resources provided for you. And if you are still struggling, please send me an email so I can get you some extra resources to help you out.